Hi Devesh, and first introduce yourself to the team members.
Sir, my name is Deversh here. I come from Moradabad, district of Uttar Pradesh. I have completed my schooling in Moradabad, and currently I am a final year student of chemical engineering at BNIT Nagpur. So during my course, I have completed 2 summer internships in marine industries site. My recent work was based on the energy efficiency audit of heavy machinery that includes boiler, thermal heater, and cooling towers. And so last year, I have done a project based intern, which was basically on the rapid composting and the pre-treatment of the paddy. So apart from this, my hobbies is to read and write Hindi and Urdu poetry. Thank you, sir.
Okay. Okay, my first question to you, as you are from Muradabad. So Muradabad is famous for which metal?
Uh, so brass. Basically, Muradabaad is popularly known as brass city, and it is the largest hub of export of brass to all over the world.
Okay, what is the composition of brass?
Uh, so basically, copper and zinc.
Okay. So my next question to you. Okay, tell me your favorite subjects.
Sir, it would be heat transfer, mass transfer, and fluid mechanics.
Okay. Why not others? Only three.
Sir, others are also important, and I do like them. But should ask about favorite subject, then these three will be the priority. And these subjects help in understanding the other subject as well. So that's why.
Okay. So my next question to you. We know that for an ideal gas, the value of Z is equal to 1.
Yes, sir.
Why?
So basically, that accounts for non or for all non-identities present in the system. So when we talk about the ideal gas law, which is EV equal to ZRT, so there when we substitute Z equals to 1, we get the ideal gas equation. So that will be the reason.
So we will get this equation from PV is equal to ZRT or Z is equal to 1, or from the virial equation.
Yeah, sir. So basically, what Z is basically in form of 1 plus B square plus B and all these terms. And for ideal gas, we neglect all
Yes,
the higher terms and
exactly.
only one is left.
I want to listen that only because all these factors are due to the interactions, and we
Yes,
know
sir.
that in an ideal gas there are no
There is no.
interactions, and when there
Yes,
are
sir.
no interaction, then all the interaction factor will be 0. So that's
Yes,
why
sir.
Z is equal to 1, and not as you define that, sir, PV is equal to ZRT. If we will put Z is equal to 1, PV is equal to RT. So you need to go in that manner, because with the help of the virial expansion, and in all the terms will represent the interaction. And as we know that in case of an ideal gases there are no interactions, so as there are no interactions, so there will be all the terms
Yeah.
will be 0. So that's why
Yes, sir.
Z is equal to 1. Okay, my next question to you. In different subjects like mass transfer, heat transfer, fluid mechanics, even CRE, and other subjects, we use dimensionless numbers.
Yes, sir.
Why do we use dimensionless numbers?
Basically, dimensionless numbers help us to relate one subject to another. Suppose if we have some information about heat transfer, so by help of dimensionless number like Nusselt number related to the Sherwood number and Schmidt number related to the Prandtl number, we can use that information by using those numbers in mass transfer as well. So that's why we use those dimensionless numbers.
That thing you told, that is the similarity, that suppose if we are going to use the mass transfer Sherwood number, then corresponding to that number we are going to use the Nusselt number in heat transfer. But why do we use, what is the basic thing behind that?
So suppose if we take an example of Prandtl number as well. So it tells about the ratio of momentum diffusivity to thermal diffusivity. If I know the value of Prandtl number, if it is higher or lower, then I can get to know that how much momentum transfer is being compared to the heat transfer. Means either my momentum transfer is more or less as compared to heat transfer. So there what I have done is I have taken two same parameters with same unit. So there I can easily compare my heat transfer as well as momentum transfer. Means
Can
which is
we say that dimensionless number will help us, that complex things it will reduce into the simple one, so that we can compare things easily? So up to
yes
some
sir.
point you
Yeah.
did. Okay, you told me that fluid mechanics is one of your favorite subject.
Yes, sir.
Then what is the basic difference between the dynamic viscosity and kinematic viscosity?
Sir, so dynamic viscosity tells me the resistance which fluid gives to the motion, while kinematic viscosity is a ratio of the dynamic viscosity to the density. So while talking about the kinematic viscosity, it accounts the density term. So
It will give you an idea of which thing.
so it will give me an idea of diffusivity. Means when I
Yes, it will give you an
yeah,
idea of diffusivity
diffuse
because its unit is meter square per second.
per second. Yes, sir.
Okay, my next question to you. Have you heard about Newton's law of viscosity?
Yes, sir.
What is that?
Sir, Newton's law of viscosity states that the stress is proportional to the velocity gradient.
Okay, this is a trap, and mostly 99.99% student did a mistake in that, because if you will go through any standard book, then tau is not directly proportional to the velocity gradient. Tau is directly proportional to the d theta by dt. And similar question they asked in the written examination of ISRO also. So tau is directly proportional to the d theta by dt, but we know that d theta by dt is equal to du by dy velocity gradient. That's why we are able to say tau is directly proportional to du by dy, and that's why we mucked up that velocity tau is directly proportional to the velocity gradient. So conceptual should be strong. Okay. Then next question from mass transfer. So we know that, okay, we have Sherwood number.
Yes, sir.
In which condition you will get the value of Sherwood number is equal to 2?
Sir, if I am talking, if I'm accounting for the spherical particle, and if the medium is very large, and all the substance present in the medium are at steady state, then for that condition, I will be getting the Sherwood number value as 2, and also the Nusselt number value.
Okay, you told steady state, but there are three conditions which it should fulfill. First condition is that spherical one, that
Yes,
you
sir.
told, that is correct, but not steady one, that is stagnant one.
Yeah, stagnant. Sorry.
Why stagnant one? Because we have correlation. Sherwood number is equal to 2 plus 0 point some 6. Reynolds number to the power 0.5. Seabed number to the power 1 by 3. So as we know
Yeah.
that medium is stagnant,
So
so
not number will
velocity will
become
be
0.
0. That's why Reynolds
Yes,
number will be 0. That's why we
yes.
mucked up the Sherwood number is equal to 2 in that case. So three assumptions. First assumption is that spherical shape.
Spherical medium.
Second one is that stagnant medium.
Mhm.
And third one is infinite medium.
And it is out.
Is it clear?
Yes, sir.
So you have told that you have done this internship in cooling tower, something you have told while
Yes, sir.
introduction.
Yes, sir.
Okay,
Boiler and cooling tower. Yes.
ओके सो अगर सीजन वाइज देखें तो किस सीजन के अंदर कूलिंग टावर की इफिशियंसी कम रहती है और क्यों?
Sir, if we say, so winter season के अंदर cooling tower की, sir, in winter season, the efficiency of cooling tower is less because the WBT of air is less. While in summer, as the WBT of air is more,
इज
so
इट विंटर और इट इज अ रेनी सीजन? स्पेसिफिक और
yes,
ज्यादा करे तो
means yeah, in rainy season, the WBT is
यस,
quite less as compared to other season. So the
यस
efficiency is
यस
less.
ओके, ह्यूमिडिटी लेवल बहुत ज्यादा रहती है हमारी विंटर सीजन के अंदर, और कूलिंग टावर का काम ही वही है ना, जो एयर आई है उसके पास मॉइस्चर नहीं रहना चाहिए। अगर उसके पास पहले से मॉइस्चर है तो वो हमारे जो सिस्टम का मॉइस्चर है उसको वो लेके नहीं जा पाएगी। ठीक है, चलो। आ तुमने जैसे हीट ट्रांसफर में कहा, हीट ट्रांसफर में क्या लिक्विड में कंडक्शन हो सकता है?
Yes, sir.
एट विच कंडीशन?
Sir, basically, conduction dominate when the liquid is at stagnant position, means the liquid is not moving. But even
यस,
if the liquid is moving, the conduction will be there.
ओके, या स्पेसिफिक विल बी व्हेन द लिक्विड इज नॉट मूविंग, दैट इज स्टैग्नेंट, वेलोसिटी इज जीरो। ठीक है, तुमने
Yes, sir.
जब डायमेंशनलेस नंबर डिफाइन किया था, एक डायमेंशनलेस नंबर पे बहुत ज़्यादा तुम फोकस कर रहे थे, दैट इज योर नसेल्ट नंबर, मे बी दैट इज योर फेवरेट नंबर। सो एक बायोट नंबर भी आता है, दोनों में क्या डिफरेंस है, दोनों के फॉर्मूले में, और क्या दोनों सेम है?
No, sir. Sir, Nusselt number we use when we want to know that how much heat transfer is enhanced by the presence of bulk motion. Basically, Nusselt number is a ratio of convective heat transfer to the conductive heat transfer. While Biot number tells us we use this number in unsteady state and basically in the lump parameter model. And Biot number is a ratio of resistance to conductive heat transfer to the convective heat transfer. This is
So it
basically
means
the difference.
there is no relation. It is just coincidence that both have the same formula.
Yes, sir.
Prox. Okay.
Yes, sir.
So
So because
you
yeah.
yeah, okay. So you told me that it is a lumped heat analysis model. We go for the Biot number. So if
Yes, sir.
lumped heat, for what purpose we use this lumped heat analysis model?
Sir, basically, if we are the heat matter model, means there is no conductive resistance around the of the body. Suppose if we are talking about films, so if the uh,
No,
thermal conductivity of
my question is why lumped heat capacity model is there? Why there is a need for that? For what specific purpose we use it?
so
Is it
basically for finding the time means
yes,
in how much in how much time the required temperature of the body will be occurring or not. So that's
yes,
means
yes,
about the
yes,
main
yes. So
question.
basically, it is for an unsteady state. Okay.
Yes, unsatisfied.
So what is the condition for applying the lumped heat capacity model?
Uh, Sir, if we are talking about the Biot number and Fourier number, then our Biot number should be as much as uh, should be less, means less than 0.01, and our Fourier number should be more. So
Fourier number
basically,
should be. So what is
higher.
Fourier number? What is the difference between Biot and Fourier's number?
Sir, Fourier number is a ratio of the heat diffusivity to thermal heat storage. Basically, it tells that how much heat is being transferring as compared to the heat is storing in that material. While Biot number is the ratio of resistance of, as I told, to the uh, conductive to convective one.
So for Biot number, what should be infinite? K should be infinite or H should be infinite?
So K should be infinite.
K should be infinite. Okay.
Yes.
So if what will happen if there is a system where H is infinite and the system is unsteady state, then how we will solve?
But if H is infinite means there is no convective resistance present in the system.
Yes.
So it means that when we will apply the lump parameter model, that temperature will be equal to the initial temperature of the body.
But how we will solve that system? You are saying that when K is infinity, go with lumped heat capacity and that famous formula T minus T 0 T minus T infinity, okay, e to the power something, okay, HMCPT. But my question is, if it is a reverse, okay,
Yeah.
if it H is infinity, K is not infinity, then system is, although is it is an unsteady state, okay, then how we will solve that system? Do you have any idea?
So, yeah. So then we can use the general energy balance equation, which is the 3D equation in the system, and yeah, we can use that equation.
No, for that we have to be depend upon the literature actually and more towards the Fourier's number. Okay. So same question is asked so many times in the gate examination also. Okay, this same question if H is infinity. Okay, so from literature survey we have to take some data of that T minus T infinity and all that. Okay, there are curves are given. Okay, if you follow 𝐁𝐚𝐭𝐡's book, it is there. Okay, so they have given this literature curves, and from there we can just find out Fourier's number and all that. Okay, so that will be there. Okay, so my next question is from the heat exchanger. Okay, so when I say 1, 2 shell and tube heat exchanger, what does specifically mean by 1 and 2?
So basically, there is one shell, and the tube portion means the shell portion is divided into two parts, such
Okay.
that my fluid is taking two loops in the means on one loop will be there. Means first will be if it is moving in rightward direction, then in the leftward direction. Means two times
Okay.
my fluid passes through the tube.
It is changing the direction basically.
Yes, sir.
Okay. Okay. So my next question is then if it is changing a direction, then the 1, 2, who will dominate? Whether it is a LMTD by co-current will dominate or LMTD by co-current will dominate?
Um, Sir, They depends on the inlet, basically the placement of the inlet and the outlet of the valve of the fluids, and then we will find the correction factor, and from that we will find the overall driving force. Means
Correction factor will be fine, that is okay, but I am saying
yeah,
just from diagram if you see कौन डोमिनेट करेगा, तुमने ही बोला है कि उसका डायरेक्शन चेंज हो रहा है। इफ द डायरेक्शन इज चेंजिंग वन टाइम, है ना, एक बार डायरेक्शन चेंज हो रहा है, इसका मतलब क्या है, इसका मतलब है हाफ जो है तुम्हारा हीट एक्सचेंजर है विल बी बिहेविंग समवॉट एज अ काउंटर करंट हीट एक्सचेंजर, और हाफ जो रहेगा वो तुम्हारा को करंट रहेगा, ठीक है। सो
yeah,
यहाँ
in
पे
that
कहीं ना
context.
कहीं हमने LMTD के साथ कॉम्प्रोमाइज किया हुआ है ना, बिकॉज वी नो दैट LMTD ऑफ काउंटर करंट इज बेटर देन को करंट मोस्ट ऑफ द
Yes,
केसेस, ओके,
yes, yes, yes,
मोस्ट ऑफ द केसेस। बट यहाँ पे हमने LMTD के साथ कॉम्प्रोमाइज किया, देन व्हाई वी से दैट शेल एंड ट्यूब हीट एक्सचेंजर्स आर एवरी टाइम अ बेटर, क्योंकि हमने कहीं ना कहीं तो LMTD को अपना डिक्रीज करने का एक मौका दे दिया, क्योंकि उसने तो को करंट के पास चला गया। then why we say always that go for a shell and tube, go for a shell and tube, and industry also everyone is using for shell and tube.
so basically heat transfer coefficient which we get in silent tube, because the convective motion is high in shallow tube heat exchanger, so the
Yes,
heat transfer coefficient as compared to other heat exchangers is more. So
yes,
that's
that is
the
very
main
much
thing.
correct, that we dominate over here is heat transfer coefficient, okay, so that helps us to make the